Hey everyone, we are live because we are going to do graph problems. I mean, revise graph problems. Um, so I haven't done advanced graph problems. As you can see, this list is not at all solved. So what I'll be doing is going through the question, number of islands. Um, Aside, something that I wanted to share, it's difficult, like mentally it's challenging, I feel, like going through all the questions that you have done already. Um and as the interview is approaching, it's kind of like, am I doing this right? What am I doing? And yeah, I don't know what's if the strategy that I'm following. I'm just revising questions, not doing much newer questions at this point of time. um, I think I should be doing newer questions, but uh, on the other hand, I also think that revising what I've done so far, solidifying my thought process on the questions I've done so far, will prove beneficial rather than just keep on going, doing new problems. So that's my plan. And uh, also I'm doing pram interviews. So today I gave one pram interview. I've also uploaded that pram interview. It was a nice experience, but I was not sure about the time complexity that I specified. It was a graph question itself. But yeah, that brings me to graph, and let's see how many questions we can cover up. I will not try to go in detail. Hopefully, um, along with you guys, I can, um, revise this in a better way. Um, yeah, like if I'm not going to code anything today, because coding and going through each and every part of the question doesn't make sense at this point of time to me. So anyone watching this video, I'm just going through the questions, and I'll try to think out loud, as it's a good practice. And yeah, that's what I'll do. Okay, enough. We are 3 minutes into it already. Let's go uh, number of islands, right? First one. So I'll just increase the font size. Never keep your cup on the right hand side. Okay, cool. Um, so yeah, here we have been given an m into n 2D binary grid, which represents a maps of ones and zeros. Return the number of islands. An island is surrounded by water and is informed by connecting adjacent lands horizontally or vertically. You may assume all four edges of the grid are surrounded by water. So I have done this question. This is a pretty basic one, basic in the sense, I mean to say, essential initial questions of graph. So in this method, they have in this problem they have given us ones and zeros. So all the ones combined together, like whichever we can traverse horizontally and vertically, like top, bottom, left, right, traversing in this four direction. If we can reach once, so we have to see that this is a land, and all that land um, which forms one becomes a entire island. And imagine, yeah, it's just like a island that you are exploring. Suppose you are stranded on an island, and then you go about searching till what part is the land, and you make, okay, so here at this edge there is a water, I cannot say that is a land. So I can keep on going wherever I see land. So that's how this problem works. So what I'm thinking is I'll start reversing from the like I have to create a two loop first of all, and wherever so basically once this question comes, I think it's essential to ask the interviewer if we can modify the inputs that are given to us, or we have to maintain another 2D matrix which specifies if a certain slot has been visited or not. So yeah, we need to clarify that, but we don't once we start reversing, we don't want to visit the same path again. So so what I'm thinking is using a hash, or yeah, something like that, using a hash, and then keep on calculating the grids. So how will I do that, right? um, okay, so what I'll do is I'll form a for loop, sorry, m into n for loop will be there. Then we'll be traversing through entire node. Whenever we find a one which has not been visited, then we start reversing it. So once we come out of it, that would be one island discovered. And the next time and then next time we like go on searching for another one, that at that point of time we have already modified the island already. So marked the island already that we have visited this, don't visit here. So yeah, that will help us, and then we can visit the rest of them, and every time we find a new one, we can update the count of a grid. So that's that. I'm so the basic time complexity of this would be m into n. M into n is for sure, but I just want to make sure what would be the time complexity. See, where m is n. I would also like to hear what Neetcode is saying, like
Let's
what
solve Leetcode 2.
Neetcode time complexity would be. So somewhere I'm looking at the thumbnails. I suppose somewhere he might have mentioned it.
Starting at the original point over here and marking each layer of ones. So in the first layer we got this, the second layer we got this, the third layer we got this, and the fourth layer we had just a single value. So this is really easy to visualize, and if you already know this algorithm, you can code it up pretty quickly. So knowing what we just learned, let's code it up. So the first thing, just do some input validation. If we had an empty grid, we don't want to have to run our algorithm, and we can simply just return 0. There aren't any islands in that case. The next thing I like to do is just get the dimensions of the grid, so the number of rows and the number of columns. We can get the number of rows by doing this, and the number of columns by doing this. We also want to be able to mark positions or cells visited when we're marking island masses, so I'm going to use a set to do that. We could also use a 2D grid if we wanted to, but I think sets are a little easier. We also want to count the number of islands. We can initialize that as 0. So we want to visit every single position in the grid. So let's iterate through each row and column. So R is going to go through every single row. C is going to go through every single column. If we visit a 0, we don't have to do anything, right? But if we visit a 1, then we have to do something. Then we have to traverse it and mark it visited. And don't forget that this 2D grid is actually made up of strings, not numbers. That always trips me up. I think it's kind of annoying that Leetcode does that, but it does. So now we have to run our traversal. I'm going to run breadth first search because I kind of like it. So run breadth first search on this cell, row, column. We also have to increment the number of islands. But remember, we're only going to be incrementing the number of islands if we get to a one that we haven't already visited. So we're going to make sure that if we execute this, we've gotten to a position we haven't visited. And then ultimately, we're just going to return the number of islands. But we didn't actually write our breadth first search. Let's do that right now.
Oh, he's using breadth first search.
So breadth first search is not a recursive algorithm, it's iterative. So we need a data structure to use for memory. So a queue is normally used for breadth first search. So we want to mark this position visited as well. So to visit, we're going to add this cell that we're about to use our traversal on, RC. We're also going to add it to our queue. And so while our queue is not empty, that means we're going to be expanding our island. So we're going to pop from the queue. And we want to check the adjacent positions of this position that we just popped. So the way I like to do that is use a loop. So we know that there's 4 directions that we can go in. The direction to the right, which is 1, 0. The direction to the left, which is -1, 0. The direction above, 0, 1. And the direction below. Now, for each of these directions, we're going to check something. First, we want to check that this position is in bounds. The way in Python I like to check that is just if r plus dr is in range of rows, and check that the column plus direction that we're moving in is also in range of columns, and that this position is a land position, so this is equal to 1, meaning it's land. And lastly, that this position hasn't already been visited. So if this is true, then we can add that to our queue because that means we have to run breadth first search on this cell as well. We also have to mark it visited so we don't visit it twice. I noticed that we're doing this computation a lot by adding row plus direction of row, so I'm going to fix that really quickly. And that's pretty much the entire breadth first search function. It's going to be running until we want to do as a pair, not 2 positions to visit. I had a sloppy. It's going to be running until the queue is empty, which means that there's no more land positions to visit. I had a sloppy bug. I forgot to add this row column position as a tuple, which we want to do as a pair, not 2 elements separately. I also used the wrong function name for visit. We have to use visit add, not append, because it's a set, not a list. And there is the breadth first search solution to this problem. Sorry about a few of the bugs that I had. I hope they didn't trip you up too much. And also, the neat thing about writing it this way is if your interview asks you at the end, okay, could you do a depth first search solution to this? You can actually do it really easily. This pop left that we wrote, if you just change it to a regular pop, meaning a pop right, it'll pop the most recent element that we added instead of the first element that we added, which means it'll basically be a depth first search. But it's non-recursive, it's iterative. If you enjoyed and if this was helpful, please leave a like and subscribe, and thank you for watching.
Okay, so time complexity wasn't mentioned. So BFS M to N, basically it's both union find. So does that change anything? Yeah, it's M into N again. Simple attempt at understanding why the space complexity is min, M, N in BFS and images. A, B, E, C, F, I. Okay, min of mn. Okay, got it. Okay, so what we'll do next is so the better solution of solving this problem might be PFS, because yeah, at any given point our queue will be holding just the longest why minimum? Maximum should be the one, right? So 4 here 0. Oh yeah, okay, yeah. So if you see at any given point, we can actually fill um, HK and Q. Yeah, 4, only 4, the smallest one. 4 and 5 are there, so minimum of 5. Okay, got it. So that is done. Then go clone a graph. Let's see this one. So clone a graph. Given a reference of a node in a connected undirected graph, return a deep copy of a graph. Each node in the graph contains a value int and a list node of its neighbors. Got it. Okay. For simplicity, each node value is the same as the node index. For simplicity, each node value is the same as node's index. Okay. Now, for example, the first index, first node with value 1, the second node with value 2, okay, and so on. Okay. The graph is represented in the test case using a adjacency list. An adjacency list is collection of unordered lists used to represent a finite graph. Each list describes the set of neighbors of a node in the graph. Each list describes the set of neighbors of nodes in the graph. The given node will always be first node with value 1. You must return the copy of the given node as a reference to the cloned graph. So if we see, if we take the length of it, length would be n, right? So that many character nodes are there in this, right? So what should we be sending in the end? So you must return the copy of the given node as reference to the cloned graph. You must return the copy of the given node as reference to the cloned graph. I see that. So it can be empty. There might be a graph which doesn't have any nodes at all. Okay. So what I'm planning to do is okay, so if I do a DFS on this one, so yeah, like basically sorry, I took a little bit of pause there, but what I'm thinking is I've done a cloned linked list, right? Clone linked list, so I've done that. So basically if I use the same strategy here, I know the number of nodes are the length of the adjacency list, right? So what I can do is I can create number of nodes in a hash map. So one would represent one's node, two will represent, and then what I can do is iterate. Yeah, what I'll do is I'll put I'll I can do an DFS approach, but if I do a DFS, see, if I do a DFS on one, I'll keep queue. I'll have a queue in which I'll keep a one. Then for 2 4, I'll run a for loop on one, basically the first index, right? So I'll get this guy, then I'll add them both to the first adjacency list, and as it is a undirected graph, I can add one to theirs as well, and then I will put them in a queue. I'll traverse them again. So 1 3 will be traversed, but one would be again in the visited list, so we won't visit it again. And then we'll put 3 in the adjacency list and put 2 in 3's adjacency list, and also visit 3. And as 2 is already visited, we won't visit it. Yeah, so we can basically do that. So we will be eventually visiting vertex into edges, like how many vertex are there, and edges are there. I guess we would be visiting those. So V into E, or is it V plus E? I guess that yeah, see, I told you guys we have to create a map, but yeah, in this case we are just creating a visited one. Node, if node equal to null, return node. So what I'm doing is, okay, if visited has node, return visited dot get node. Got it. And let clone node is equal to new node value, node dot val. Oh, everything is a node, right? This is node. Okay, got it. So yeah, basically we have to return the node then. Okay, I got it. So what would be the time complexity of this? I guess V into E should be the one. Or N plus M. N is number of nodes and M is the edges. Okay, so yeah, that makes sense. But why is my time complexity getting screwed? Where N is the number of nodes and M is the number of edges. Okay, yeah, we are using a visited hash map, so it's reducing our count, so N plus M. Okay, got it. So we did clone graph, and let's see how important is this. Sorry, my internet. Okay, pretty important. Thousand Eyes. What is this company? Thousand Eyes. Thousand Eyes. Okay. And this is pretty popular question. So yeah, a lot of companies like to ask it. So we'll mark it. We have already marked it. This question is also important. Next what we'll do is we'll take a 5 minutes break, and then we'll come back and do the next one. So I've as of this time I won't turn off anything right now. I will but play kind of a music and just go lo-fi. Okay, so I'll be right back. Hey guys, we are back and let's solve next question, which is max area of land of island. Okay, sorry. So in this question, you're given an mn to n binary matrix grid. An island is a group of ones representing land and connected four directionally, horizontally or vertically. You may assume all four edges of the grid are surrounded by water. The area of an island is the number of cells with a value 1 in the island. Return the maximum area of island in grid. If there is no island, return 0. Okay, I sorry, I was thinking something in my head, but I'll give it one more go. So you are given an m into n binary matrix grid. An island is group of ones connected four directionally. You may assume all four edges of the grid are surrounded by water. The area of island is the number of cells within value 1 in the island. Return the maximum number of an island in grid. If there is no island, return 0. So yeah, what we can do is we can basically again um, search for once and we can have a visited one, and this time whatever we visit once, we have to calculate the number of ones that we are encountering, and every time we encounter a one, the next path should be incremented, right? So let's say if I encounter a 1, I'll send 1 along with it, and okay, so what I'm thinking is I'll add 1 to every path that I'm going to, and if that path is um, not an island, then we won't go forward. But at what point should we stop, you know? Like if I want to, or you know what, I as I'm going through it, okay, once I reach on to the one, what I'm thinking is I'll send back a one. So yeah, that's what I'm going to do. If I see a one and that particular edge is one, then in the end I'll going to send one. So eventually when I will, so let's say if I encounter this one, I will come on to this. I'll go here, I'll return whenever we are going out of bound or onto a zero, we'll return zero. And if we are going to one, then okay, let's do this. Then we'll go here, then we find this one, go here. So this is our last stage, right? So here we get zero from all the paths, and then we add one and then send one. So this guy got one from this guy, right? So it will add its own one and then send above, and then this will continue, and then we'll be sending the one from the where the function was called. And finally we can just update the maximum island that we have encountered. So this will be again m into n, and space complexity would be m into n if we are doing DFS. If we are doing um, let's say PFS, then minimum of m or n, right? Space complexity, in terms of space complexity. Yeah, see, that's what I was saying. uh, you gotta send DFS for that grid, and every time, yeah, we just add one for everything and return zero. So yeah, that's what we are going to do. Cool. So that's that. And let's quickly see if our, yeah, r into c, and if we iterative, we just use a stack and then we use pop. Okay, cool, got it. Let's do another one, the Pacific Atlantic water. And basically these, I guess these question, and we did not see how important this question is, and it's a lot important. A lot of company like to see. I never saw DE Shaw, like I never saw open position for DE Shaw on LinkedIn or anywhere else, and LinkedIn is super slow for me. I don't know why. If you haven't observed it, or if you have observed it, I don't know, but it feels super slow. I know I'm streaming right now, it might be slower because of that as well. uh, but whenever I'm not streaming, it's pretty slow. It takes time to load. I haven't read article about it. I do follow this D Shaw group, New York. Okay, I'm not sure what investors across the world. Okay, are they having okay, no, there are no jobs at all in D Shaw. And I've heard it's one of the good paying companies, but yeah, as you can see, no jobs at all. Okay, guys, so what we were doing is Pacific Atlantic water flow, right? Oh, yeah, this question gave me a hard time last time. So let's see if this question does make any sense at this point of time. I had to watch Neetcode's video to understand what was going on in this question. It's been a while I've solved this, but let's give it a shot. So the question says there is an m into n rectangular that um, island that borders both Pacific Ocean and Atlantic Ocean. The Pacific Ocean touches the island left and top, and the Atlantic Ocean touches right and bottom. Okay, the island is partitioned into a grid of square cells. Mhm. You are given m into n integer matrix heights, where heights r and c represents the height above sea level of the cell at height height of r and c represents the height above sea level of the cell at coordinate r and c. That makes sense. The island receives a lot of rain, and the rainwater can flow to neighboring cells directly north, south, east, west. If the neighboring cell's height is less than or equal to the current cell's height, water can flow from any cells. Water can flow from any cell adjacent to an ocean into the ocean. Okay. Return a 2D list of grid coordinate result denoting that the rainwater can flow from cell Ri to both the Pacific and Atlantic Ocean. Got it. Okay. So the question is like, if from any given cell can we reach to the Pacific as well as to the Atlantic Ocean? If we see the problem, 6 can definitely reach Pacific Ocean, right? But 6 water can flow north, south, east and west. So 6 can flow to 5, which is obviously smaller than the 5. So this can go to Atlantic Ocean, and this guy 7, okay, 7 can go to 6, and 6 can obviously go to this, so this is also the one. How is 5 also coming in? So yeah, if you see 5 3 1, this can go, and 5 4 2 1, this can also go this way. So that's why it is in the in this, like it's part of the answer 4. So I guess even if we have same height building, does it allow the water to flow? I guess the water would be flowing from 4 3 1 instead of 4, direct 4 4, and 4 can obviously go here, and then I guess water can flow to same height buildings. So 4 4 goes to the water, because this 4, for it to be part of the answer, this 4 should travel to Pacific Ocean, and this 4 is going to go here, and then 3, and then above, right? So that is that, and 5 can obviously go anywhere like this, and yeah. So I know this question is pretty tricky, and you cannot, like, I was not able to solve it in the first go. um, Many of you might have, but for me it was bit tricky to understand what's exactly going on. um, so I'm trying to think what can be done, what can be done in this question. So give me a minute, let me think about it, and hopefully I can come up with a solution. So I'm thinking. I'm thinking of checking if any of the corner, like I remember, like, to be honest, I remember how it was. I'm trying to remember how it was solved. So partially what I can remember is, um, we have to take the um, column, like the left column, and check. So left column can obviously go to the Pacific Ocean, but we want to check if it can go to the Atlantic Ocean as well. So let's say we go to 1. Let's say we go to 1, and then what we want to see is if the next cell that we are visiting, if it is greater than, yeah, if it is less than or equal to. But if we are going from this portion to the inner side, then I'm not sure, like, how will it be doing that. You know what, I'll just see what I've done in past and probably do this. So I can see I've taken the row length and column length, then Pacific visited and Atlantic visited I've created, like 2D matrix, um, row length and column. Okay, so 2m into n, and then first visit Pacific and Atlantic row vertically. Okay, so DFS I 0. So 0th column I will visit heights of I and uh, heights of I and 0. Okay, height of I and 0. Okay, got it. And then horizontally, this we have to visit Pacific and Atlantic horizontally. Okay, so once we do that, then what? So okay, so r equal to row length greater than equal to row length. Return. So So what is the condition if visited equal to true is there, and parent of, if parent value is greater than height RC, then return. So let's say we traverse to from 1. 1 is not greater than 2, then I keep on going this way. 2 is not greater than 2, then 3 is not greater than 2, 5 is not greater than, then this becomes true. And similarly we can go down as well, right? 1 is not greater than 3, 3 is greater than 2, so we return. So okay, what we are doing is we are checking for both Pacific and Atlantic visited, if from that portion we can visit Atlantic or Pacific. Okay, that is smart. But wait a minute. Wait a minute. Okay. So I can reach, so I'm checking the vertical first. So I can visit this guy. So I'll mark everything Pacific visited. I'm going from this guy, then I'm marking Atlantic visited. So eventually at every node I'll be marking that particular cell that it can visit Pacific, and yeah. So this might not be very as we are maintaining, anyways we are maintaining the a table of visited or not. I guess m into n would be the time complexity. Yeah, m into n, and space complexity is also 2 into m into n. 2 is constant, so we get rid of it. Yeah. Okay, this is pretty intense, I would say. Like this one I will categorize as the question. If you have seen the question that, yeah, we have to find the product of the array, all the array except the index, like yeah, so it's kind of like, because we have to maintain the left and the right, and then we merge both of those. So it's kind of like that. It's not that intuitive, this one, and hopefully this is not asked a lot in the interviews. Yeah, it's not asked. Some companies do like to ask this, like TikTok and Intuit. In, in Sorry, Intuit. Sorry, my bad. Intuit. But yeah, Intuit. So I guess we did a good job. We did around 1 hour of study. So 1 hour of revision. We were able to just do 4 of these questions, like just revisiting them normally. But what I'll try to do is take a break take a break, and then we can get back to solving more of these questions. Like let's try to get done four of these more, and yeah, let's try to do it as many as possible. Uh, let's not give up on this. Let's do it after a break. Okay, so till then, um, do some time pass or anything. Talk to you later, guys. Bye bye. Not good at it, I know. I'm not good at it. It's okay. I'll get there someday. Once I get land a job, I'll start posting a polished version of this solving videos. Okay, cool.